Welcome back. Some time ago, I made a video discussing why the tension is constant on a mass string. Today, we will consider a more realistic scenario of having a heavy rope or a chain. What does this bring to the system and why you usually don't deal with it in your physics classes? Okay, now consider the system with blocks mass m1, m2 with m1 greater than m2 and the mass of the rope being m. Assume that the rope has uniform mass density and it is symmetrically placed. Can you calculate the acceleration of the system when it is released from rest? I'll give you a few seconds. So it will accelerate with A equals m1 minus m2 divided by m1 plus m2 plus m times g, the acceleration due to gravity. Since I was just planning to give you a conceptual overview and keep the video short, I am not going to show much of the detailed calculations, but if any of you need it, let me know in the comments. I will post a video detailing everything. But keep watching the video, I have a lot of interesting situations for you. So if you followed my previous video, you would already know that the tension won't be constant. But try to see if you can find exactly how it is varying. First, consider the 2 points where the masses are attached to the rope. Take your time and try to calculate the tensions T1 and T2. The tension T2 would be the force needed to pull the mass m2 against the gravity and give it a net acceleration a. So its equation of motion can be written as T minus m2g equals m2a. That gives the tension T2 equals m2 times g plus a. And similarly, the tension T1 is given by T1 equals m1 times g minus a, or it can also be written as m2 times g plus a plus ma, if you write in terms of the masses it is pulling. But that is not even the whole story. The situation is much more complicated. The situation at each point in the chain is different, as the mass it has to pull is constantly varying. For example, at the top of the pulley, the tension in the chain would be given by m2 plus m by 2 times g plus a, and at the halfway points on each side of the rope, the tensions would be m by 4 times g plus 3a plus m2 times g plus a. And on the right side, we will have m2 times g plus a plus m by 4 times g plus a. Now, let me ask you another question. Is the tension in the string even constantly decreasing? Give it a thought, pause the video, and check again. If you said yes, you are correct, but only under a specific condition. The tension would constantly decrease from the point of contact at m1 to the point of contact at m2 only if the acceleration a is less than g. But when acceleration a is greater than g, the tension in the chain increases as you move from one end of the chain to the top and then decreases to the other end. Even more interesting is the case when a equals g. Here the tension everywhere in the left side of the chain will be the same, but it decreases as you move down on the right. How cool is that? Even I got excited seeing all this result while I was calculating for this video. But you cannot get the values of a acceleration this high just by releasing it. You would need some kind of system to pull it from the left side. So for the simple case of releasing the blocks from the rest, we can still safely consider that the tension to be constantly decreasing. Now, can you think of what happens after it starts moving? Is the acceleration constant? The answer is again no. As the system starts moving, the weight distribution of the chain also changes. More of the chain would be on the side to which it is moving to. This creates another mass difference, and the resulting acceleration can be written as a equals m1 minus m2 plus delta m divided by m1 plus m2 plus m whole times g, where delta m is the mass difference of rope on either side. So the acceleration of the system keeps increasing till all the mass is flipped over the pulley and everything can undergo a free fall together with A equals G. This is probably the reason why it is probably not taught in schools, as they only dwell in the kinematics and the constant acceleration. In addition to being so complicated, the system doesn't even have a constant acceleration, and that's why you never learn it in schools. But it is quite possible to have such systems like this for competitive exams, so you can try to give it a good understanding of it. So all the best for the rest of your studies. See you later.